All right, so let's go through the 2-3 notes on solving one-step inequalities with multiplication and division. So let's first go through this table to kind of see if we can determine if these values for x are possible solutions to the given inequality. Okay, the given inequality is 3x is greater than or equal to 6. So we want to substitute 0 for x. 3 times 0 is 0. And 0 is not greater than or equal to 6. Substitute x equals 1. Actually, let's do all the operations first. So now we're going to check to see, is 3 greater than or equal to 6? Is 6 greater than or equal to 6? Is 9 greater than or equal to 6? And is 12 greater than or equal to 6? So x equals 0 is not a possible solution. 3 is not greater than or equal to 6. So x equals 1 is not a possible solution. 6 is greater than or equal to 6. 9 is greater than or equal to 6. And 12 is greater than or equal to 6. So now let's graph the values that were solutions on the number line. So x equals 2 is a solution. X equals 3 was a solution. X equals 4 was a solution. So that means that anything else greater than 2 would be a solution if we follow that trend. X equals 0 was not a solution. X equals 1 was not a solution. So those values were not included in the shading. So then if we were to go to solve, we have 3x is greater than or equal to 6. The inverse operation of multiplying by 3 is dividing by 3. So we have x is greater than or equal to 2, which is correctly graphed based on our little investigation of testing those values. Okay, now let's work on the inequality. Negative 3x is greater than or equal to 6. So let's do all of the operations first, and then we'll test the solutions next. So negative 3 times negative 4 is equal to positive 12. Negative 3 times negative 3 is equal to positive 9. Negative 3 times negative 1 is positive 3. Negative 3 times 0 is 0. And negative 3 times 1 is negative 3. So now we're going to plug in that value into our inequality. And we'll see which values for x are possible solutions to the given inequality. So 12 is in fact greater than or equal to 6. 9 is greater than or equal to 6. 6 is greater than or equal to 6. 3 is not greater than or equal to 6. 0 is not greater than or equal to 6. And negative 3 is not greater than or equal to 6. So negative 4 was a solution, negative 3, negative 2, not negative 1, not 0, and not positive 1. So we'll start at negative 2, and we'll shade to the left to follow that trend of possible solutions. And now let's check the solution. So right now we're multiplying x by negative 3. So when we divide by negative 3, we get x is greater than or equal to negative 2. Okay, now the issue is this inequality does not match the graph we made, nor does it match the table. Okay, and that's because we divided the inequality by a negative number. Okay, so there's one little stipulation when we're solving inequalities that involve multiplication or division. And that is, so all of the rules for solving equations apply, except when multiplying or dividing by a negative number. Okay, once you do that, so if you multiply both sides of the inequality by a negative or divide both sides of the inequality by a negative, the inequality symbol must be flipped. Okay, so if we revisit that example and we go divide both sides by negative 3, it's this step here, because we divided both sides by a negative 3, that we have to flip the inequality symbol. So the correct inequality would be x is less than or equal to negative 2. And that, if we look back at our graph, that matches the graph that we made based on testing those possible values for x. Okay, now it's not if you get a negative number, but it's if you actually multiply both sides by a negative or divide both sides by a negative. And I use this symbol, this little asterisk here, I use that whenever my next step is to flip. So you'll see that a lot on all of my answer keys and on all of my notes. It's a nice helpful reminder that we did divide both sides by a negative, so we need to make sure that we flip the inequality symbol. So now let's do some practice. For number 1, we have 3 times x is greater than or equal to negative 9. So the inverse operation would be to divide both sides by 3. And we get x is greater than or equal to negative 3. Okay, we didn't multiply or divide by a negative, so we don't need to flip the inequality symbol. Fill out our number line. Negative 3 is included in the possible solution, so it's going to be a filled in circle. And it's greater than, so we're shading to the right. For number 2, we have y divided by 6. So the inverse operation would be to multiply both sides by 6. So we get y is greater than 12. Twelve is not greater than 12, so it would be an open circle at 12 because it's just greater than, and shaded to the right because it's greater than. For 3, we have 3/5 times x, so we're going to multiply both sides by the reciprocal. The reciprocal of 3/5 is 5/3. You can multiply the numerators and then the denominators, or you can cross cancel. 12 over 3 is 4 over 1, and 4 times 5 is 20. So we get x is less than 20. Open at 20, less than shaded to the left. For 4, we have negative 4/9 times y. So we're going to multiply both sides by the reciprocal, negative 9/4. Okay, so because we multiplied both sides by a negative, we want to make sure we flip the inequality symbol. You can multiply the numerators and then the denominators, or you can cross cancel. 8 over 4 is 2 over 1. 9 over 27 would be 1 over 3. So the product of 8/27 and negative 9/4 is negative 2/3. So we had less than or equal to, so we want to make sure we flip the inequality symbol to be greater than or equal to. And for the number line, I'm going to make my increments to be 1/3, just so my number line doesn't have to be an approximate solution. So if I'm increasing, my next value would be -1/3, and then 0. And then for decreasing values, I'd have -3/3, which is -1, and then -4/3. So -2/3 is included. So we want a filled in circle. And it's greater than because we flipped it, so we want to shade to the right. You don't have to do increments of 1/3. You can just do -1, 0, 1, and then approximate where -2/3 would be. But since we're making our own number lines, they might as well be exact. For number 5, if we look on the side with the variable, we're multiplying x by -2. So to solve, we're going to divide by -2. And we divided by a negative, so we want to make sure we flip the inequality symbol. So we get 3 is less than or equal to x. And because the variable is on the right, if we want to rewrite it so that it's on the left, we want to read the inequality from right to left. X is greater than or equal to 3. So it would be closed at 3 and shaded to the right for greater than. And our last inequality. So look on the side with the variable. We're multiplying y by -4. So we're going to divide by -4. Again, we divided by a negative, so we want to make sure we flip the inequality symbol. We want to rewrite this so the variable is on the left to make it easier to graph. So read from right to left. So I get y is less than -6. -6 is not included, so we want an open circle. Less than, so we shade to the left. Okay, so whenever you multiply both sides by a negative or divide both sides by a negative number, you must flip the inequality symbol. Okay, we've got 2 word problems, and then we'll do some practice. The Science Club charges $4.50 per car at their car wash. We want to first write an inequality to represent the situation, and then solve to find out how many cars they have to wash to earn at least 300. So how we would determine the amount of money they're collecting is we would take the price per car, multiply that times the number of cars, And we want that amount to be at least whatever their total goal is. So we don't know the number of cars, so we're going to let x equal the number of cars. And now fill in the values. So the price per car is $4.50. X represents the number of cars. At least, that would be greater than or equal to. And their goal is 300. So 450 times x is greater than or equal to 300 is the inequality that represents the situation. And now we want to solve. So we'll divide both sides by 450. And we get x is greater than or equal to 66.7 cars, which means they have to wash at least 67 cars. So whenever we're talking about objects, we want to round to the nearest whole number, and that whole number has to be greater than or equal to 66.7, so the answer would be 67 cars. But the solution to the inequality is x is greater than 66.7 cars. And the last word problem. Suppose you earn $7.25 an hour at your job. We want to write and solve an inequality to find how many full hours you must work to earn at least $100. So to figure out how much money you would earn, we would take the amount per hour times the number of hours. This amount has to be at least whatever the total amount that you want. So the piece that we don't know is we don't know the number of hours. And now let's fill in what we know. So we make $7.25 an hour times X number of hours. At least is greater than or equal to, and we want to earn at least $100. So there's the inequality that models the situation. And when we solve, we want to divide both sides by 725. So the value of x, or the solution to the inequality, is x is greater than 13.79 hours, which we can interpret to at least 14 hours. Because it specifically states how many full hours must you work. So the next full value would be 14. That's greater than 13.79. But it's still helpful to include the solution to the inequality and then interpret what that means. Okay, so that's it for the 2-3 notes on solving inequalities using multiplication and division. The key takeaway is to make sure that you flip the inequality symbol whenever you multiply both sides by a negative or divide both sides by a negative number.